Now we would like to identify what is an electric current. So an electric current here is simply the rate of flow of electric charges through a conductor. A conductor here means something which conducts electricity, something which allows the flow of electricity. As an example of conductor is the copper or the aluminium, okay, which is a good conductor of electricity. It loves electricity, it passes the electricity. So here this one is a wire which is made of copper or aluminium or any conducting material. So the electric current is the rate of flow of electric charges, the rate of flowing of electric charges through the conductor. We can say also the electric current is the time rate of change of a charge, and this current, electric current, is measured in ampere, which is a scientist. Now, in order to find the equation, the electric current is simply the rate of flow of electric charges. The rate means the differentiation with respect to time, okay, of electric charges, which is Q. Q representing our electric charges, and it measured in coulomb. So the current is dq over dt, or the rate of change of, or the rate of flow of electric charges, which is measured in coulomb with respect to time. So 1 ampere is equivalent to Q, which is the coulomb, over the time, which is second. So from this equation we can say that the Q, or the electric charges, is equal to the integration of the current dt from the initial time t0 to any time t. Okay, so if we would like to find the electric charges at any time, then we will integrate the current from the initial time to any time we would like. So this is the electric current. Current I here is moving from the positive to negative. So let's delete this one. Okay, so to avoid confusion. So see that here we have the positive and the negative. The current flows here from the positive and going through the negative. And so the direction here is in this direction, since the current is moving. Okay, so the positive to negative is the direction of the current. We say that our current is from positive to negative, but actually the flow of electrons is from negative to the positive. Okay, the flow of this electron causes the current. Okay, so scientists would have or had chosen to select the direction of current from positive to negative. This is what they would like to do. Okay, that is what they did in electric current. Now, electric current has two main types. One of them is called the direct current, or the DC current, that remains constant of time. As an example of this, the direct current, you will see that here we are drawing the current as a function of time, the variation of current with respect to time. As an example of this, the battery having a current which is constant with time, which is this one. The current have a one directional or a directional current which does not change with time. This we can say that this one is a DC, a direct current having only one direction. This one is considered as a DC too. Why? Because this one is always positive. Remember that this part, this one is 0. From here, any value here is considered as a positive. So the current actually it changes, but it is always greater than 0. Okay, 0 or greater. It is a positive value. It has only one direction. This one is another wave called the full wave rectification. These two waves are discussed in my own course for power electronics. But anyway, the second type, in order to understand the difference, is the alternating current or the AC current, which is the source in our home. This one can vary sinusoidally. What does it mean? It can be like this. This one is called the sine wave. This is the pure wave which appears in our supply, on our AC supply. So see that here, during this part, the current is varying, but it has a positive value greater than 0. So it has a positive direction. In this case, it has a negative value. Okay, so the direction of current is reversed. Here, again, positive value. So positive, negative, positive, negative. So the current is alternating. It is changing with direction. Sometimes it is positive, sometimes it is negative, and so on. Another example is the square wave, which appears in some kinds of inverters. Also, I discussed this wave in the inverters course. So we'll see here that it is sometimes positive, then go to negative, positive, negative, positive, negative. This wave is also an AC wave. Okay, so we have here some positive currents, and which having one direction. They don't change with time as a direction, not as a magnitude. So the direction is the same. So this means that we have a DC current. AC current means that our current is varying with time. Positive, negative, positive, negative. So if we get back to our circuit to understand, if we have a battery is considered as a DC supply. DC supply means that our current is constant. We're having a constant direction. So our current is always in this direction, positive to negative. Now if we have an AC supply and connected to a load, example a resistance, so sometimes, of course, we represent our AC supply with this value or this sign. Sometimes the current will be here. Sometimes the supply is positive, negative. So the current goes from here. And sometimes the current reverses its polarity. That means that this one became the positive and the other one is the negative. So this one is the positive and the negative. So in the negative cycle, it moves in this direction. So the current is said to be alternating between positive direction and negative direction. Okay, this in the case of AC supply.